Thank you very much, Jakob. Following my previous speaker, I can show an image of a monitoring station. That's one of our monitoring sites that has been in use for about 15 years now, where we continuously measure the pass-by of each train. Actually, it's not us as an infrastructure manager doing this, it's our authorities. So that way, we have quite a good knowledge on what is on our tracks. But now I'm going through the noise sources we have, and then in a second part, I'll tell you about the mitigation measures and the future work we are doing. The first, obviously, is traffic noise. We have been hearing about a lot about this. Aerodynamic noise is not that important for us because we don't have that much of a high-speed network, and the high-speed network we have is mostly underground. What we do occasionally have is curve squeal, has also been a subject today, and we will try to reduce that also. Then the noise TSI is a bit of an issue, and I liked really much the idea that was presented by the group that we make access charges based on measurements, because the TSI measurement is kind of a one shot with a perfect vehicle. We heard that the vehicle mostly belongs still to the supplier at the time when the TSI limits are measured, not even to the operator that will use it through its service life. And so therefore it would be really beneficial for us to have an actual measurement, because even though rails might degrade with service, we've also seen some rail roughness measurements, might be the same thing for the vehicles, and that currently is not yet looked at. And of course, we also like to have the quiet routes regulation, and there we might also have to face ourselves as an industry and ask why it has been taken so long since the invention of the quiet break blocks until we now have some actual regulation in place that will give this benefit to the line side residents that we have. I'm being honest with you. I talked about the TSI measurements that are on a perfect track. Not every track is perfect. We might see some issues on our tracks during service life, because we also have to use our tracks from new till we reach some intervention limits. And on the, let's say, on the second half of this life journey, there might be some issues about noise. One famous example is the big picture is a rail joint that when it degrades, it will give a certain noise. That's actually quite a nice example. On the journey here, I saw a worse one, but I didn't take a picture. Then the top picture are switches and crossings. Also there we have wear on the frog, on the nose, that can lead to complaints, to additional noise. Also there we need to be quite fit and quick with repairs, or we will have noise complaints. It's not only noise, because noise on a switch, for instance, is not stands not alone. Noise comes from a large impact, and if we don't do anything, then the impact will also degrade the switch quite rapidly, and we might have to use more and more expensive maintenance measures compared to if we fix it right away. Then here a little bit, I have to see where I get my. Here we see a rail right after grinding. We heard that rail grinding is beneficial for removing corrugation, but directly after grinding, the surface has quite a rough finish that might also lead to tonal effects that can give complaints for the first few days or few weeks after a rail grinding event took place on the network. And then, rather exotic, we have also electrical sparks. We just had some complaints in the few weeks that were very cold in the last month. And this is something that only happens in winter and not in summer. We already heard a lot about parked trains. This can be a little bit frustrating subject for us as an infrastructure manager, because legally we are responsible for parking noise, but we can't really do much about it unless we just say to the operators, you can't park here anymore, and that's not something we would like to do. And also the normal noise barriers might not work because the noise generating equipment on trains is often on the roof. And we also had complaints that last very long, for several years, where the people already have a noise barrier, but still are not happy with the parked trains because just the noise sources are too high up, and they might also live a little bit on higher terrain, and it just it doesn't work. And then we can say we have built a noise barrier, where's the problem? And these discussions tend to be rather lengthy. Solutions are not that easy. We cannot tell our customers, the operators, to park somewhere else, because then maybe the train drivers will have no way of getting to and from the parking location. And that really is a source of a lot of discussions. Then, of course, we can't forget one of the noise sources that's not covered by regulation, but is a very important part of our life, is construction noise. It's often during the night, and especially in Switzerland, when we have 2 tracks, like here the track that is not worked on is usually in service. So we also have to have warning equipment in place that warn our workers from approaching trains. And even if the work they do doesn't require the big equipment, the work itself would be a bit quieter, then the warning bells and sirens will wake up the residents, and they might even be less amused about this when they don't hear construction noise. When they hear construction site, they realize, they need to be warned. But when the work itself is quiet and they just hear the alarms, then the perception is a little bit different. And also here, communication works. I'm not a line-side resident, but my mother is, and she always sends me a message when she receives a letter from the railway that they will do some work. And I never get noise complaints for her. So there, when people are involved and know why we do things and how we do things, when we do things, the acceptance level is higher. And also one specialty we have is when we work through the night, then during the day, also this track here will be open again, and it's not going to be in perfect shape. So this is a track that is being renewed currently, and you can see here the dips that come from the work in progress. Then here the ballast has not yet been fully compacted, and that then leads to noise emissions during the day. They will of course be gone once the construction site is finished, but it's not only in the night when the big yellow machines are working that there's noise, sometimes also during the day, and this can get on the nerves of line-side residents. And of course, we try to avoid that. This is not the standard. This was a bad example, but it can happen. Then we have also a bit more exotic, let's say, noise sources that are attributed to infrastructure. Might not be the case for the upper picture, but it is door signals and loudspeaker announcements, mainly on rural stations at night. So if there's the last 2 trains close to midnight, nobody's getting off, or one person is getting off, no one is getting in, then there's the door signal for the last person going out of the train. There might be a loudspeaker announcement and there's no one there. And also there we have had complaints from residents close to stations. If we can't omit that, but of course we can't, we have to find a solution. There might be once a person that needs the announcement, and we cannot just turn off the speakers after a certain time. So what can we do about it? The obvious and rather effective solution is noise barriers. They are effective, but also those have some drawbacks. Here we see the site facing the tracks, where it looks quite nice, but the outside might be having some graffitis that not everyone likes. And then it's just a wall, so the sound barrier is also a visual barrier, and some people don't like it. When we built all these noise barriers, we had sometimes complaints that we don't build enough, and also complaints that we build too many of them. Then obviously the higher levels here are not protected. We still need mitigation measures there. So we had to install soundproof windows to protect those residents also. And then we have some organizational issues, limited track access for maintenance, and for emergency services, we need to have emergency exits that need to be maintained. And last but not least, we also had some studies showing an effect on wildlife migration paths that are blocked. There are also some different measures that are feasible for very local applications. Don't know if you can see it here. Here are friction modifier nozzles that for this curve here apply a friction modifier after every so and so many axles. We have a few of those systems, are not that happy about them because they have an effect, but they don't eliminate the problem completely. So it is sometimes hard to communicate to residents that when we say it could be worse, it doesn't feel like a good position to be in when we just tell them that. And then also what has been tested at several sites in Switzerland, but then has been proven to be not feasible with our construction method of the track are dampers. You can see here these black elements between all the sleepers are the damping elements that can reduce the vibration of the rail, can detune it so that the rail radiated noise is decreasing. The efficiency then depends on the actual superstructure that is used. Then we heard a lot about several topics of ongoing research, and we also do the same. I'm not gonna say much about novel rail paths. We'll hear about this tomorrow, what is going on there. Rail roughness has also been a subject. There's also a talk tomorrow that talks about this, how we could proceed there. Curve squeal is also something that we are interested in, and we would like to see more details on the effect of the vehicle. So is it really for all the vehicles? Are some vehicles standing out? And these vehicles that stand out either in a positive or a negative way, how can we address the features that cause this, and how could we learn from that? Then, of course, there are also mitigation systems for the vehicles. The brake system I already mentioned, the cast iron brakes, and there's a wheel dampers. And for construction, we now have an incentive to our construction companies. They should look at battery-powered construction equipment that could reduce the noise of the transportation if they have to drive back and forth on the track. Of course, if they still are digging big holes with compressors, that's gonna make noise, but then at least it's concentrated the place of the noise source, and all the back and forth, the removal of the material will be quieter. And what I personally like is these novel sound barriers that would then just be an option to have a sound barrier that is kind of transparent because it has an upside effect. So that would be, for once, an option to increase the height of existing noise barriers without actually building something. And also the people affected might still have a view and still be protected from the noise. Of course, we also have some issues, some conflicts. We've already heard it also today, more traffic, more noise, even if the trains as individuals become quieter. So that's an issue when we hear about new regulations, new limit values. It's just hard to achieve with more noise when we get quieter on the vehicle, but the amount of traffic that we have, that we want, will irradiate this effect again. Higher speed is not everywhere feasible. The high-speed lines have their own issues on noise. I'm not going to comment on that because we don't have too many of those. Then generally, also the first point that has been brought up by the focus group, it's of course true. More mitigation is more cost. Everything we build in track will also cost. And it's not only the investment that's important for us, it's also the maintenance, the procurement, the maintenance, replacement, and the renewal of these different elements that we have. It's just everything we put additional in track will have this whole series of events that will be triggered by that. And then the friction modifiers, we also try to use them on a train instead of locally, but then we had run into some problems with environmental issues when we don't have a localized application of these grease substances. We have it on the whole line. So that's also something to keep in mind. And then as the last point, I want to close the circle to the first session that we had, to policy. We as infrastructure managers cannot just imply any noise charges, any noise penalties on railway undertakings. We really have to have the legal framework in place that also we can incentivize our customers, the operators, to do a quieter job, what they do with their vehicles. Well, as with most of the discussions here, I can only say we are working on it, we are making progress, but we can still do more, and I hope also sessions like this will help us do that.